We decided to do our project on the biomechanics of a free throw, and we will be comparing Amanda's free throw to Kevin Durant's. Kevin Durant is a NBA player for the Golden State Warriors. He won the 2013-2014 National Basketball Association MVP award. So our initial question was, how does height, velocity, and angle of release affect the trajectory of their free throws? So we were going to be looking at many different components to a shot. Some of those include release, height, arm length, their height in general, and the size of the ball they were using. For Amanda, that was 28.5, which is a woman's size ball, and for Kevin Durant, it's 29.5, which is a men's ball.
For some of the science about free throws, the optimal amount of spin is about 3 revolutions of backspin from the time it leaves the hand until it hits the rim. It's recommended that you aim for the back of the rim and not the center of the rim. The optimal amount of degrees should be about 52 degrees. Release the ball as high as possible above the rim. This allows for the greatest possible chance of going in. And release the ball with a smooth body motion for consistent release. This helps with the routine of keeping consistent motion.
The free throw is the most mental part of the game. A lot of times when you come up to the line, you're going to be tired, you're going to have a fast heart rate, your legs might be shot, and you're going to be out of breath. So you have to really take advantage of the 10 seconds they give you to shoot the ball. A lot of players will make a free throw pattern so that they can mentally prepare themselves for the shot. So for myself, when I receive the ball, I take a deep breath, and then I'm going to line up my foot to the nail of the free throw line, which is the middle of the court, basically. And then I'm going to take 2 dribbles and release the ball. There are a lot of different free throw patterns that certain players have. I know KD likes to get the ball and spin it, and then he'll dribble it, spin it again, and do a shimmy before he shoots.
Alright, so before we dive into the biomechanic principles, I want you guys to take a second to yourself and think of the 2 most important biomechanic principles involved with a free throw shot. So now to dive into the actual biomechanic principles that we came up with. The first one we had come up with was coordination. You need to coordinate movements of your muscles and joints to have the proper velocity in order to make the free throw. I mean, you really have to coordinate the muscle actions and have the proper timing for your shot. Segmental interactions. This is a concept where it increases as distance from the hoop increases. You really need to transfer your energy down through your ankles and just up the kinetic chain up until release point. And then range of motion, it was really about finding a happy medium. Low range of motion, you have higher accuracy, and then obviously a high range of motion, a lower accuracy. So really to get that optimal angle and make the free throw or any basket in this case, you really have to find a happy medium for your range of motion. Spin is another important concept when taking any shot in basketball. You really need the correct amount of spin. It really becomes important in order to get that forgiving bounce off the rim, or the shooter's touch, as they like to call it, I guess.
So gravity is the biggest force that acts on a basketball. It pulls the ball vertically towards the earth at 9.81 meters per second. Gravity is what causes the ball to have a parabolic curve to it, and then the spin that's added to the ball will distort that curve slightly. Buoyancy is the second most important force on the basketball, and it acts upward on the basketball, so the opposite direction of gravity, and is caused by air pressure differences around the ball, and then the weight of the ball also factors into that. Air resistance or drag also acts in the opposite direction of the ball. Factors such as the ball's weight, size, such as the difference between a men's ball and a women's ball, will come into play for this. The Magnus force is what is caused by the backspin on the ball. The backspin of the ball will distort the parabolic curve to make the ball go up steeper and then more or less drop down steeper into the basket. This kind of spin is what gives the quote-unquote shooter's touch and a more forgiving bounce on the basketball.
Okay, so next we have the free motion diagram of the free throw, including all of the forces that we just went over in the last couple slides. So first is going to be the preparatory stage where he's holding the ball and preparing to shoot, and then the wind-up phase where he's summing up the force. And the force phase is when the ball is actually released. So we have the gravity force as well as the normal force and the ground action force. And then on the ball we have gravity, force buoyancy, force Magnus, and force drag.
Okay, so back to our initial question, how does height, velocity, and angle of release affect the trajectory of their free throws? So basically our initial hypothesis for this question was that Amanda was going to use more of her lower body because she needs more force to get the ball to the rim compared to Kevin Durant, who is taller and doesn't have to push the ball as far. So for our initial comparison, we wanted to look at height, wingspan, free throw percentage, the basketball used, and which hand they are. So for Amanda, she's 5'8", her wingspan is 5'6", and her free throw percentage is 76%. For her, she had to use a women's basketball, which is size 28.5, and she's right-handed. As for Kevin Durant, he's kind of conscious of his height, so he's most likely taller than 6'9", but on all the rosters it says 6'9". His wingspan is 7 feet 5 inches. His free throw percentage is 88%, and the basketball size used was 29.5. And he's also right-handed, so this came into play when we were taking the footage of their free throw. We had to make sure they were both right-handed. When watching these videos, make sure to watch Amanda's lower body. You'll see that she uses more of her knees and ankles to project the ball to the rim. As for Kevin Durant, he mainly winds up at his hips, and he doesn't really use his ankle or his knees as much as he uses his hips. Here is a picture of the release angles for both Amanda and for Kevin Durant. You can mainly see that the biggest difference is at their ankle extension. Amanda has a lot more extension in her ankles than Kevin Durant. And also something to look at, especially in these pictures, is the elbow extension. Amanda uses her elbow a lot more than Kevin Durant just so that she can get the ball to the rim. Here is just a picture without the actual release angles, so you can see their joint angles more clearly. And again, you can really see Amanda's ankles are more extended. Her body is leaning forward, whereas KD is more leaned back, kind of more relaxed. You can see Amanda really has to use her body to project the ball to the rim. For angle comparison, you can see on the y-axis is the degrees of the joint, and then on the x-axis is time, and Amanda's in blue and Kevin Durant is in orange. And you can really see how Amanda's ankle degrees change a lot more than Kevin Durant's. This can be seen with her lowest point being at 68 degrees and her highest point being at 128 degrees. For their knee comparison, Amanda's knee also changes a lot more than Kevin Durant's. You can see that his line is almost straight, whereas Amanda's changes significantly more so. For their hip comparison, KD actually changes a lot more than Amanda, and you can see that with his highest point being 178 and his lowest being 137, he kind of winds up and he doesn't use his lower body as much as he just hinges at his hips. For their shoulder comparison, it's pretty much the same, and it should be because of the mechanics of the shot. Really, they have a very similar line on the graph. As for their elbow, you can see that Amanda has a lot more change in the degrees compared to Kevin Durant. This is probably because she holds the ball more in the shooter's pocket in order to have more power to get the ball to the rim. Here is our overall comparison, and you can really see here that Amanda uses her ankles and knees more so than Kevin Durant, who uses his hips. So for the physics behind the shot, we wanted to look at initial velocity, and so we had to plug in a couple different components in order to get this initial velocity. So one thing we had to look at was how far the free throw line was from the basket, which is about 15 feet. Then we had to factor in the height of the basket, which is 10 feet. We also had to factor in for each of them their release height. So for KD, that was 2.4 meters, which is about 8 feet. And then for Amanda, her release height was, let's see, 2.1 meters, which is about 6 feet 8 inches. And then we also had to factor in their angle of release, which for Katie was 55 degrees and for Amanda was 50 degrees. And once we plugged in all these factors into the equation, Katie's initial velocity was 7.2 meters per second, which is 23.6 feet per second, and Amanda's initial velocity was 7.6 meters per second, which is about 25 feet per second.
All right, so here we're looking at the optimal angle of a free throw shot. The probability, this is showing the probability that free throw is made. Here along this axis we have the actual probability that the shot will be made, and along this axis is the, sorry for the not so straight line, this is actually the release angle. Now we see that KD has a release angle of 55, so his angle would be right here, so this would be right about here, be his probability that his shot would be made. Now this chart is based off of a study that we found online, so this may be based off a few different numbers, but I mean, we all know that the probability that KD makes a free throw shot is a little more than 30%. Now we know Amanda's optimal angle was 50 degrees, which actually isn't even on this chart, so I guess we can come to the conclusion that she's off the charts.
This graph shows the optimal velocities at certain release angles. So on the horizontal axis would be the release angles, and on the vertical axis would be the velocities. So Amanda's release angle was 50 degrees with a velocity of 7.6 meters per second, which would fall right into the realm of optimal velocity, so right around here. And then Kevin Durant's release angle was 55 degrees, and his velocity was 7.2, so which made his just around down here. So he was actually slightly off the graph, so we can infer that Amanda's probably better.
Alright, so velocity is the rate that the position of an object changes relative to time, and smaller velocity implies better physical control. So from this information, we can tell that Amanda's velocity, which is 7.6 meters per second, and KD's velocity, which is 7.2 meters per second, obviously KD has better physical control than Amanda does. And there are also certain release angles that correlate to a specific velocity and increase the probability that the shot is made.
Okay, something else that factors into the trajectory of the shot is the approaching angle. You can do the math for the approaching angle, but we decided just to really focus on the initial velocity. So what we learned for approaching angle is basically the more arc you have on your shot, the easier it is for the ball to fit through the rim. If you see to the right, the picture shows an arrow pointing down into the hoop and it says 90 degrees. So here the rim looks its largest which the rim is 18 inches, so the ball could fit perfectly through the rim at this angle. But something that is really important to take into account is that your initial velocity suffers with the more arc you have on your shot. So you would have to significantly increase your initial velocity to have a shot that would approach the rim at 90 degrees. So this is kind of impossible. So more realistically, you should try to shoot with an arc of 52 degrees, anywhere between really 45 and 52. So you can see that as the arc of the shot decreases, so here at 30 degrees, in the picture to the left, the rim looks only like it's 9 inches. And then at 50 degrees, the rim looks 16 inches. At 70 degrees, the rim looks 17.25 inches. And finally, at 90 degrees, the rim looks 18 inches. So mainly the points to learn from this are that the more arc, the easier it is for the ball to get through the rim. If one uses more arc, they need a higher velocity. The best trajectories pass through the hoop somewhere between the center and the back of the rim, and taller players should shoot closer to the center while shorter players should aim more towards the back of the rim. And if someone is struggling with their free throws, they should try to make their release velocity consistent, and they should release the ball at a slightly higher angle than the average shooter. One way to measure approaching angle is with a device called the NOAA shot tracker. And so basically what this device does is it tells you your approaching angle, and the box is located on the wall next to the basketball hoop, and the little tracker device is about 10 feet from the backboard. And ideally you want to shoot the ball with 45 degrees for the approaching angle and 11 inches deep into the basket. So this device will give you verbal feedback after you shoot the ball every single time, and it will tell you what your approaching angle is and if it's too high or too low. And your goal is to have a 45-degree approaching angle. And then it will take all this data, and you can download an app, and it will turn it into different graphs and charts for you to look at and see what your approaching angle is and if it's consistent and where the center of the ball goes through the rim. So it's a very crucial device for individuals who want to improve their approaching angle. Finally, we have 4 major takeaways, and the first is the taller you are, the better free throw shooter you should be. This is because taller players have more room to make errors in both release angle and release velocity and still have the ball go in the basket. So taller players who are poor free throw shooters like Shaq are either shooting at the wrong angle or inconsistent in their release angle, or both their release angle and release velocity.
Alright, so our next major takeaway is that the shorter you are, the larger the release angle should be. And this makes sense physically, as shorter people have more vertical distance to cover when shooting.
The third takeaway is that the best shot does not go through the center of the basket. The best shots actually go closer towards the back of the rim.
So the fourth takeaway that we can take from this is that players who miss mainly due to their lack of consistency in their release velocities can improve their chances by shooting at a higher angle.
The biggest thing that we learned from this is the relationship between velocity and release angle. The worse control of speed that a person has, the greater the throw angle that they need. And then vice versa, the better control of speed they have, the lower the angle they can afford to shoot at.